Okay, welcome guys. Today we're going to discuss about introduction to high voltage lab. Okay, from the learning outcomes will be we need to get familiar and adapt the safety knowledge and standard operation procedure SOP for handling high voltage laboratory work. We also will learn how to do troubleshooting
Okay.
tasks for recognizing the important section of high voltage instrumentation. Okay, first about the safety. Since this is a high voltage lab, we need to know the severity of shock received when a person becomes part of an electrical circuit affected by three primary factors. These factors are the rate of flow of current through the body measured in amperes, the path of current through the body, and the length of time the body is in the circuit. The other factors which may also affect the degree of shock are the frequency of the current phase of the heart cycle when shock occurs, and the physical and psychological condition of a person. There are absolute no limits or even known values which shows the exact injury from any given amperage. Okay, here you can see the standard given amperage and the level of damage it can do to our body, where if it's less than 0.5 milliamp, there will be not much sensation. Then there is 0.5 to 2 milliamps where the threshold of perception is mild. And after that, 2 to 10 milliamps, the muscular contraction mild to strong can happen. After that, 5 to 25 milliamps, there will be painful shock and inability to let go, where you'll get stick to the circuit lah. If it's over 25 milliamps, violent muscular contractions can also occur, while 50 to 200 milliamps means ventricular fibrillation. After that, there is also over 100 milliamps where paralysis of breathing which can occur. Okay, from the above table, it describes the difference only about 100 milliamperes exists between a current which can be perceived and one which can be immediately fatal. Okay, then now we will move on with the frequency converter, which will be described by Shamimi. Thank you.
Firstly, we are going to trace power cable skirt, which is starting from isolated switch, which is 415 volt, to the power block terminal and distributed to the controlling circuit system and internal transformer of the frequency converter. That is the connection from the internal transformer to the out terminal block of the frequency converter. Again. The three-phase was connected to 1, 2, 3 and the PE is for the ground of the input cable. If the input cable provide neutral ground, then this can be connected to neutral. But it is not need. For input protection, there are visitors between the three-phase and the PE. Next is the circuit for power input. In laboratory, there is a 2 times 220 kilovolt at primary and secondary transformer. So there are terminology parallel and terminology series. If we do terminology series, that is 2px to 2pu, it will get 100 kilovolt at secondary transformer. Secondary transformer is the potential from grounding point to higher point, that is 0 volt up to 100 kilovolt. If terminology are connected in parallel, the secondary transformer will present as 220 kilovolt. The most important is the earthing have to join to USO. If not connected, the grounding from primary and secondary, they are incomplete circuit and no supply of potential. The terminal PN1 to PN6 is terminal for measurement that up to 7 volt RMS. Then, next is the connection of HTAG lamp plus horn. Okay, bawah. This is good for the lamp and horn, which is potential free for customer use. In laboratory, the auxiliary terminal lamp plus horn is connected to the cage system. In laboratory, every cage have their own alarm. It is for double safety for students and people that involved in laboratory.
Okay, now I'm continuing to the trace of the interlock system, which can determine the circuit of the system and how the connection of the interlock system in the frequency converter to the sensor. So there is one connection of the interlock system in the gate. Then the example of the circuit, which is shown above, is the interlock is used to the monitor to the HV, the high voltage part of the system, and to the monitor if the ground rod is taken out from the high voltage. It can also to be the door in the safety fence mounted around the high voltage part. You can also use the delivered hearting plug with the 6 pins to the connect the interlock. Take care the two normally closed contacts are used together. The interlock works with the dual channel operation, so it will be monitored the discrepancy time between the two contacts, and it has a cross shot detection to prevent the connecting and the two circuits together in a fault case. In laboratory, the interlock is connected to the door. If the door is opening, the injection will not operate. Then the door closed tightly, normally closed. If the reset button alarm was pressed, that shows the green light. It means the induction mode is active. Okay, now I'm going to explain about the emergency button. The emergency button there are two emergency button, which is the if the second emergency button stop is not used, the plug is to be bridged. At least one emergency button has to be connected. If suddenly anyone enters, there should be immediate action and everything inside the cage will be activated. When there is hang in the system, it will be automatically active the grounding switch. And this is the two times of the connection emergency stop in the modular kit of the cabinet. And there is a type of cable the uses is the shielded cables must be used for the emergency connection. And the description for the emergency buttons, when pressing the emergency button, there's opens the two output contact and the input contactor of the kit of frequency converter cabinet. So there is no voltage at the power output from the frequency converter cabinet. There should be take care that the two normal cross contacts are used together. E-stop works with dual channel operation. It will monitor the discrepancy time between the two contacts, and it is the cross of the short detection to prevent connecting this from two circuits together when fault case occur. So now person will be explain the grounding system.
Okay, for the frequency converter grounding, the appliances can be used for either 50 Hz or 60 Hz. From the circuit, we can see that it is grounded at test bay. The FC cabinet has a copper foil connection to connect cabinet with low inductance to test area ground. Here below, we can see in the image that we can see the ground switch connection also given that 812X1 hard link plug with 10 pin. From the circuit, we can see that the ground switch is always switched to grounded position when software is HV off and power off, and it is always ungrounded when software is HV ready or HV on. The grounding switch automatically activates when exceeds certain threshold. The cable used for the grounding is copper braided cable, which is used for grounding and earthing. Here we can see the example. The equipment grounding has its own rod and must touch the water spring. The resistance of the grounding must also be below 2 ohm. Grounding enhancement material can also be used to reduce resistance, and the grounding of HV lab building must be very low potential. The resistance also must be very low. The kit is grounded separately at only one position to the ground rod, while this is to avoid ground loops between grounding point. Okay, from the building, we can see that the normal grounding is separate from the equipment grounding. Our frequency converter has its own grounding rod. Thank you.